Welcome everyone to this explainer on EventSauce. I am absolutely thrilled you're here. So EventSauce is this brilliant, really lightweight PHP library that's specifically designed to make event sourcing a whole lot more accessible. Our goal today is incredibly specific, but also incredibly powerful. We're going to map the entire event sourcing lifecycle. We'll trace a simple HTTP request all the way through a PHP application using EventSauce. By the end of this, you'll have a crystal clear mental model of how this architecture actually works in the real world. Okay, let's dive right into this. I want you to imagine something for a second. What if your database didn't just store the current, right now state of things, but literally remembered every single thing that ever happened? Every tiny change, every decision, permanently recorded. That is exactly the magic we're unlocking today. Here is our exact roadmap for building your mental model today. 1. The event sourcing paradigm. 2. Commands, making the decision. 3. Storing truth, the event store. 4. Queries, building the dashboard. 5. The complete architectural flow. And finally 6. Best practices and mistakes. Part 1, the event sourcing paradigm. To truly grasp event sourcing, we actually need to unlearn a few things first. We kind of have to rethink how traditional apps save data. Most of us are used to traditional CRUD, right? Create, read, update, delete. When you update a record in a CRUD system, you just overwrite the current state. The old data is gone forever. You completely lose the history of how the system got to that point. Event sourcing completely flips this on its head. Instead of saving the current state, we append immutable facts to a log. We save the actual history of what happened. Because if you think about it, if you have the full history, you can always figure out the current state. Plus, you now have this ultimate, unbreakable source of truth. Moving to part 2, commands, making the decision. This is where user intentions enter our domain. For today's explainer, let's pretend we're building an appointment booking system. Think of a command simply as an object that represents a user's intent. It's what the user wants to do. It's always named as an imperative action, like book appointment or reschedule appointment. But here is the absolute key. A command is an intention. It's not a fact. And because it's just an intention, a command can absolutely be rejected if it happens to violate any of our business rules. So who actually decides if a command gets accepted or rejected? Well, that is the job of the aggregate root. When a command comes in, a command handler loads the aggregate root. You can think of this object as the strict gatekeeper of our business logic. It checks all the rules, protects the invariance of our system, and ultimately makes the final call. And this brilliantly illustrates the concept. Think of the aggregate root as a super strict manager. You hand this manager a request, the command. The manager looks at the rules, looks at the current situation, and either says, nope, no way, you can't double book that time, or says, all right, request approved. Now, once that strict manager actually approves the command, it records a domain event. This is the exact opposite of a command. A domain event is an undeniable, immutable fact of something that has already happened. It's always named in the past tense, like appointment booked or appointment rescheduled. You can't reject an event simply because it's a historical fact. It already happened. All right, part 3, storing truth, the event store. Now that we have all these undeniable facts, we need to talk about exactly where and how they get permanently saved. This is where the message repository and the event store step up. The event store is the physical database infrastructure where our domain events are permanently appended. To actually get them into the database, EventSauce uses serializers. These turn our beautiful PHP event objects into JSON payloads. We can also use message decorators here, which is super handy for attaching metadata, like a user ID, a correlation ID, or a timestamp, without polluting our clean core domain logic. To really lock this mental model in, think of the event store as an unbreakable history diary. Once an entry is written in ink, it can never, ever be erased or modified. And the serializer? Well, that's just the translator who takes the manager's verbal decision and formats it perfectly into text so it can be written straight into the diary. Let's look at how this builds our system's state over time. You might be wondering, if we only save history, how does our manager, the aggregate root, know what's currently going on? It does this through a process called Aggregate Replay. When a new command comes in, the repository fetches all the past events for that specific appointment from our history diary. It literally replays them in chronological order. First, it was requested on day 1, then rescheduled on day 3, then confirmed on day 4. By replaying these facts, the aggregate perfectly rebuilds its current state in memory. meaning it can accurately validate the very next command. Part 4, queries, building the dashboard. So we're writing a ton of history, right? But here is a massive golden rule. You should never query the raw event store to build your user interfaces. Doing that leads us to CQRS, Command Query Responsibility Segregation, which is a fancy way of saying we need to split our write logic from our read logic. On the query side of things, we use projectors and read models. A projector basically just sits around listening for new events that have just been saved. When it hears one, it translates that historical fact into a flat, highly optimized data structure. And that's the read model. This read model is designed strictly for one thing: incredibly fast front-end queries. So, the crucial point is how these roles seamlessly interact. Sticking with our real-world analogies, after the event is saved in the diary, the message dispatcher acts as the delivery person. They swiftly hand a copy of the event over to the projector. The projector is your report maker. It reads the event and updates the read model, which is the actual dashboard your users are looking at. The dashboard doesn't make any decisions. It just shows the data as fast as humanly possible. Part 5, the complete architectural flow. Now it's time for the really fun stuff. Let's combine all these pieces into a single, cohesive lifecycle. Imagine a user clicks Reschedule on our appointment app. Here is the exact day in the life of that request using a lightweight framework like Slim PHP and EventSauce. Step 1. The Slim root receives the HTTP request. Step 2. The controller creates a command object and passes it straight to the command handler. Step 3. The handler loads the aggregate root by replaying history, and the aggregate checks the business rules. Step 4. The aggregate approves it, recording an event, which is then serialized and appended to the event store. Step 5. The dispatcher immediately notifies the projector of this brand new fact. And finally, Step 6. The projector updates the read model database, and our API instantly returns a fast JSON response to the user. It is a beautiful, clear, one-way data flow. To keep all this flow manageable, a clean folder structure is absolutely vital. Your Slim controllers and HTTP logic need to stay completely isolated in the HTTP folder. The domain folder holds your aggregates and events, and it must never, ever know about Slim, your database, or JSON. The infrastructure folder handles the EventSauce plumbing like serialization. This strict separation ensures your core business logic remains perfectly pure and untouched by infrastructure concerns. Finally, Part 6. Best practices and mistakes. We are in the home stretch. I want to make sure your implementation is truly production-ready and free of the traps that catch out almost every beginner. Now, what's really interesting about this slide is how easily our old CRUD habits try to creep back into event sourcing. You absolutely must avoid putting business rules in your Slim controllers. Keep them firmly in the aggregate. Also, never put database queries inside your aggregates. They should only rely on their own past events. Do not use events like generic CRUD updates. So don't make a generic appointment updated event. Make it specific, like appointment rescheduled. And whatever you do, never go back and mutate old events in the database. If the structure of an event needs to change as your app grows, use EventSauce's event versioning and upcasters instead. Because our domain is totally isolated from the database and the framework, testing becomes honestly incredibly elegant. EventSauce encourages a behavior-driven given, when, then testing strategy. You basically say, given these past events have occurred, when this new command is dispatched, then this specific new event should be recorded. You're literally just proving that your manager, the aggregate, is making the right decisions based on historical facts. No database mocking required at all. Before you actually push this live, run through this rapid-fire mental checklist. Ensure you have strict CQRS separation between your commands and queries. Make sure you're using message decorators to track correlation IDs. Trust me, you'll need that to debug requests through your logs. Have your upcasters ready for when your event schemas inevitably evolve. And definitely write integration tests for your projectors, since they're the ones actually touching the read model database. And that brings us to the end of our explainer. We've taken a single HTTP request and traced it all the way through commands, strict aggregates, immutable historical events, and lightning-fast read models. I want to leave you with this final provocative thought. Look at the current state-heavy, CRUD-based app you're working on right now. How might you refactor its most complex domain using these event sourcing principles to guarantee a perfect, unbreakable history? Thank you so much for learning with me today. Go dive into the code and start building your history.